Welcome back. Today we look at the types of data visualization. This has been broken up into two parts, 1 and 2. So what we have here is the graphical representation of the data. What are the common graphical data representations? We'll be taking a look at what are line graphs, bar charts, scatter plots, bubble plots, and pie charts. What are they and when are they used? We'd also be taking a quick look at how to visualize big data. These are the days of big data, so we should have at least a basic understanding of how to visualize big data when we would have to handle it. Graphical data representation. Well, like I had mentioned in one of the earlier lessons, not all data should be represented in a similar way, right? The type of graph that is used to represent data depends on specific scenarios, such as nominal data is represented in pie charts. Okay, it is good to represent nominal data in pie charts. Does that mean you cannot represent nominal data some other graphical formats? It's not that, but it is best to represent it as a pie chart. From the earlier lesson, we know what a nominal data is, right? Data which can be classified, but there is no ranking between the classes. Similarly, ordinal data, right? The data which are classified into different classes and there is a ranking between the classes, right? These sort of data, which we call ordinal data, or even discrete data, are often represented in the form of bar charts. Okay, we saw an example of what a bar chart looks like in the data visualization lesson. For data which are continuous in nature, right? Continuous variables, histograms, frequency polygon, or frequency charts are commonly used. These are primarily representing data in the statistical analysis of the data, are represented using histograms, frequency polygons, etc. If we need to summarize data over time window, right? How much of rainfall has happened over the last year or over the different months of a certain year, which is also called a time series data. Okay, we use a line plot for the same. Let us understand what each kind of these data representation graphs are about. Line graphs. The name suggests a line graph or a line chart shows a relationship between one variable and another. Okay, and it looks like some kind of a curve in your XY plane. Okay, so x-axis represents one variable, the y-axis represents another. They are mostly used to track changes over time, how a certain variable y has varied over time x. Examples again would be the change of stock prices throughout the day, the measure of average temperature over a period of time, etc. If you look at the chart here, it shows examples of line graphs. On the left, we have month as the x-axis and sales figures as the y-axis, and we are able to track the sales volume over the months of January to May. The figure on the right is again a line diagram. Here it is tracking two different parameters, okay, over the same axis. One is the percent recycling that has happened and the total waste that was recovered from 1960 to 2011. So that's what a line graph is, a simple representation of data, okay, or which sort of shows a relationship between one variable and another. Next, we look at bar charts. So bar charts are commonly used for comparing the quantities of different categories or groups, right? So we saw in a couple of previous slides that ordinal data, okay, data which can be ranked, is often represented in the form of bar charts. The values of a category are represented by the bars, alright. They can be configured with either vertical or horizontal bars. So the categories, the value of each category is represented by the height or the length of the bar, okay. And you can have a vertical bar chart or a horizontal bar chart. It really doesn't make much of a difference as to which one you choose. Examples would be rainfall for each month of the year or population across different states, etc. Here in the example, the left chart shows the genre of films and the frequency, okay. So frequency would represent like how many people on an average enjoy that genre of film. So comedy seems to be enjoyed by most, followed by drama, sci-fi, horror or thriller, etc. Okay, and the right bar chart, which is a horizontal bar chart, shows a very interesting data that has been captured. Excuses for being late to class, alright. So what are the different kinds of reasons the students have given for being late to class, which varied from I had no clean pants to wear, which was sort of a third ranking. I forgot to set my alarm, which is the maximum number of students came up with this excuse or reason, and so on and so forth. Okay, so bar charts basically represent the value of the category through bars. Usually on one axis there would be the category of the classes and the other axis would represent the value of the category. Next we come to another different kind of chart called a scatter plot. Little different from the other kinds of charts that we have seen or discussed till now. The scatter plot is basically a plot of a two-dimensional plot, okay, where the variation of one variable with respect to the other is plotted. It is useful for examining the relationships or correlations between the variables, say x and y. So, how does x or y vary compared to the values of x? See, variables are said to be correlated if they are dependent on each other. Okay. For example, profit is correlated to revenue or related to revenue, right? As revenue increases, profit also increases most of the time, right? So when two variables move in the same direction, when one increases, the other also increases, it is called a positive correlation. If they move in the opposite direction, say x increases, y decreases, then it is called a negative correlation. And if there is no relationship, we call it no correlation. Scatter plots can also help to identify patterns presented in the distribution of the data. Okay, so just looking at the data points, oftentimes we are able to find out some patterns within the data, whether all data is clustered together, similar, the values are close to each other, or whether the data is very, very spread out, or most of the data are close together, they have similar values or close values, while some of the data have extreme values which we call outliers. So your scatter plot helps to determine these factors within the data very easily. It is helpful when you have many data points. Otherwise, it really doesn't make sense to create a scatter plot. If you are working with a small set of data points, bar charts or tables may be more effective way to display the information. Next slide, let's take a look at what a scatter plot is. See, it is a plot of salary versus the price of the car. Okay, and the graph is saying what your car says about your salary. So these blue dots are the scatter plots. Okay, so we see that as the price of car increased, okay, we could assume that the salary of the person increased accordingly, right? People with a higher salary tend to buy cars which are costlier than people with a low salary income, right? So these are some kind of information that you could extract or conclude from the data just by looking at this scatter plot. A very simple plot, but it gives you a lot of information about the data that you are analyzing. Hopefully that gives you some kind of a basic understanding of what a scatter plot is. We would get into more depth of how to create these scatter plot graphs using Tableau in subsequent lessons. Well, that's all we had for the part 1 of this lesson. Thank you till we meet again.